What if you could launch and control an MCP server directly from your client code with just 2 lines of Python? You'll see how to instantiate a StdioTransport that not only starts the server as a subprocess, but also gives you full control over its command, arguments, and lifecycle, all while keeping the connection lightweight with keep alive equals false. This pattern is perfect for testing, local development, or any scenario where you need to manage the server's environment explicitly.
Transport equals StdioTransport. Command equals Python. Args equals server, Py. Keep alive equals false. Client equals client, transport.
This demonstrates the transport abstraction pattern for client-server communication. The code shows explicit transport configuration, where the transport object encapsulates all connection mechanics while the client remains transport-agnostic. What makes this distinctive is the separation between connection strategy and business logic, allowing you to swap transports without changing client code. The pattern works by treating transports as pluggable adapters that handle environment management, process lifecycle, and protocol specifics. Here, the StdioTransport manages subprocess execution and IPC, while the client only knows it has a connection, not how that connection works. This inversion of control lets you configure low-level details, like environment variables or command arguments, at the transport layer, keeping your client code clean and portable. This approach solves the problem of environment coupling and deployment flexibility. By externalizing connection details, you can run the same client code against local subprocesses, remote HTTP services, or in memory instances without modification. The trade-off is that you must explicitly configure environment isolation for subprocess transports, but this explicitness prevents subtle bugs from implicit environment sharing. Let's break it down line by line.
Transport equals StdioTransport.
This initializes a transport layer using StdioTransport, which handles communication via standard input-output streams. It's the foundation for process-to-process communication, enabling the client to interact with the server, Py script as if it were a local subprocess.
Command equals Python.
Specifies the base command to execute the server script. This ensures the system uses the correct Python interpreter, preventing environment conflicts when launching the subprocess.
Args equals server, Py.
Specifies the command line arguments passed to the Python interpreter when launching the server process. Here it designates server, Py, as the entry point script, ensuring the transport layer executes the correct server implementation. This mirrors how you'd invoke the server from a terminal with Python server, Py.
Keep alive equals false.
This disables process persistence after the client disconnects. Without this, the server, Py process would linger in memory, wasting resources. Critical for test environments where clean shutdowns prevent state leakage. This closing parenthesis terminates the StdioTransport instantiation, finalizing the configuration for process-based communication. It completes the setup before passing the transport object to the client constructor, enabling the connection to the server process.
Client equals client, transport.
Instantiates the MCP client using the pre-configured transport. This establishes the connection to the server process we defined earlier, enabling RPC communication between client and server. The transport parameter handles all low-level connection details. StdioTransport configuration. The StdioTransport manages server processes as subprocesses, handling environment isolation, lifecycle control, and communication through stdin/stdout pipes. Environment variables must be explicitly passed to the server process, as the default isolation prevents inheritance from the parent shell. Setting keep alive equals false forces complete process isolation between connections, essential for testing, but costly for repeated operations.
The transport that launches servers becomes the server's first client.